Hello everyone and welcome to the next video in this series of tutorials for the CAD-NX practical course. And today we're gonna have a look into this part right here, which is number 9 in the technical drawing document and called O3 Hoop Guard. As always, our typical procedure of modeling is having a deep look into the technical drawing and making our plan of what we want to do before we actually start. And with this part we have the nice feature of the technical drawing that we have a 3D representation, which is always very helpful, at least in my opinion, to get a general overview of what we should do. And we see it's this arc right here, and two different elements are connected to it. Looking at the other three representations, we see that this should be from the side, so looking from here, or from the other side, that is. It makes no difference in this case because it's symmetric. We can see that it is symmetric because we have this symmetry line right here. I hope you can see that in the video. And also we have this symmetry line right here. And you can see also here. Okay, actually I might be wrong right here. That is not a symmetry line in this case, but I think that is the guideline, which you can also see here, here, and here. And this guideline is defined in this technical drawing, as you can see, with the radius right here and these measurements. And that's the line for these two elements. So that's one thing we learned, and the other thing is that right here has this base, and that seems to be the base for these two elements, by the way, right here. So here we see the base or the cut layers, and here we can see the necessary additional dimensions for modeling this part. It says that it's 16 high, then it has an arc with a radius of 10, and so on. So, and now we know, okay, we need to do 3 parts, that one, and that one. Seeing this line right here screams for the sweep along guide function, or the swap function, which are 2 new functions that we're going to learn today, and that will help you model a little complexer things than just by using extrude and revolve. Still, extrude and revolve will be the more important ones for the exam, but you definitely also need to know this one, and it's no big deal anyway, so I'd say we just jump right into it and you will see how to do it. And I would suggest that we start with modeling this guard right here, so that we can afterwards be concerned about these two, and we already have a reference where we need to connect them and everything. And my idea for these two is even to not model them separately, but I'm doing one, and then I want to mirror it in this middle plane right here. And to make that easier, to already have plane to mirror it right here, I want to have our coordinate system, the 0, 0, 0 point right here, down here, so that this axis right here, maybe I can draw it to make clear what I mean. So I want the coordinate system to be here, because then we have one of the axes like that, one of the layers, basically, and I want to use that right here to then mirror it later on. I hope that's clear, and that's my plan, and let me do that now. So I hope you can see it. I'm starting inside of Windows, opening NX. it's always a bit weird right here with that screen. It's obviously because I have to separate it. There are no licenses available, so maybe a quick refresher. Maybe someone didn't do it. Give me a second. So the licenses, if you have that problem, you need to go to one of the videos I have uploaded right here. I think it's a startup video where I show how to install the licenses. I'm gonna do it off screen just to save a little screen time. Okay, here we are back again. I hope it worked with stopping the video. And now I have opened the NX in a new model, and also I have rearranged my screen a little bit so it's a bit easier to look at. Yeah, and now we want to start with the plan that we made. And the first thing is modeling this, as already said, and we therefore have to start with this, with drawing this cut right here. So I'll select the y-x axis, which is the top axis, and the tutorial is annoying. Okay, so select that one. And now drawing this shape is pretty easy. We see the height is 4, that smaller side is 4, and the bigger side is 6. Therefore, we have 1 in between, so it's symmetric. That's all we need. And then we also need the distance to the middle point, because I said I wanted to have that exactly right here in the middle to make modeling a little easier later on. And I think it's not directly given here how far apart this is, but we can take a look here and find out that we have 14 from this line to this line, and these lines are the end points of the 2 circles. Yeah, so we know then that half of this is 7, because we want this distance, remember? Half of this is 7. Then we have a radius of 10, which starts right here because it's 90 degrees, as you can see. That's then also right here there are 10, obviously, and also right here there are 10 millimeters, okay? So we can just simply add 7 to the 10 millimeters, and then we already have 17 millimeters, which should be the outermost line of our sketch right here. Okay, so let me do that. I have to zoom in a lot, and also I want to close this browser right here because it's annoying. Okay, or make it smaller at least. So we go roughly to 17. It doesn't have to be exact right now, we can do that later on. And from here we want, I want to do it like this. We want a line. I'm doing it really roughly right now just because I think that's a bit more convenient to do. So I'm not doing any of the measurements yet, because I think that's a nice little trick that makes work easier. So we have the rough shape, and now we start doing the measurements by left clicking, and you see my eyes seem to be perfect. I've already done it exactly 6 millimeters, and here exactly 4. Okay, that's 1 in a million chance probably. Well, I guess it kind of snaps to the millimeters, but still. We want this, and it's okay. That one I didn't nail as much, and maybe we also need to state it here. As you can see, if I select 2 points, then it gives me 3 options, by the way, and I want to choose. Oh, I think yeah, it worked. I want to choose that one because that's what it's given, and it couldn't be edited as requested. What it is in there, or isn't it? Well, looks good so far. We just need the height actually. So let's do the dimension between the top line and the bottom line, and that's a bit off. So we need 17 here. And we of course also need this height. We haven't specified it yet. It's 4, as you can see from the technical drawing. All right. So far, so good. It looks a little bit as it would be too close, but let's wait until we have the final product to see if I read something wrong, but I don't think so. And our sketch is fully defined. One more thing that I want to check is if the middle points of these lines are exactly on the axis, or or if, for example, this line is exactly the same distance to here than this. And we can look at this in the View tab. No? Okay, we can only do that. What I showed last time, but I just realized the analysis, the measurements, we can only do that outside of the sketch. So here, to make sure that this is exactly centered, you can grab this or click this line, and then you can grab the middle point right here. And you can also select this one, and now you see, okay, it's already, it has a dimension of 0. That's of course one way to do it. You see, it's 0, the distance. And you can also use a constraint, which is maybe make midpoint aligned would probably work, but make coincident is the one that I was looking for. And here I can select the point and this line, click on OK, and now we can be sure that it's centered, because I have laid the midpoint of this line onto the y-axis. So I finished the sketch. And let's see, there it is. And now we need to do this shape. We could do this shape with tools that we have so far, and that would be extracting, also using extrude, and extruding this sketch 16 millimeters up, then revolving it around an axis that goes here, if you can imagine this, so that it revolves around this axis, then again extrude, revolve again, and extrude. We could do it like that, but the easier way, definitely, and the way that works for other things too, which are more complicated, because finding these axes isn't always as easy as it would be here, and it's not even that easy here, so it's a lot of work, and we can make that a lot easier if we use a function that is sadly not findable in here anymore, as far as I know. I can look, but I don't think it's here. Doesn't look like it, but we still have the search, luckily. So quick reminder, the search is always there to help you if you can find something. And we need a function that is called sweep along guide. You can see the first one looks like this. Make sure you have the correct one. Sometimes if you search, there are multiple functions and not everything is right. But we need this sweep along guide function right here. And let's have a look at it. What do we need? We need a section, just like with extrude and revolve too. But now we need a guide, and that's something new. So we need a guideline, which can be used to take the section and project it along this line. Okay. So I would say that the easiest line that we can use for this is just draw this outer rim, because we also know already where it starts, and that's exactly the middle point of our sketch, or the end point. You will see that soon. We have to go into this layer, of course, on this plane, because we have to draw it like this. And now we can start, go somewhere here, and we can do the exact measurements later, or we can just type it in now, it doesn't matter. 17 and 0. Now we want to go 16 up. I'm going to the profile function. Then I'm gonna do, let me see. Yeah, I'm doing it roughly again. and then later I will be doing it more, or I will give all the dimensions, because as already mentioned, that's my favorite way of doing it. So we have the rough shape. We click here, and that has to be a radius of 10. That has to be 14 in length. Here we need a radius of 10 again. And here we need 16 again. We want the midpoint of that one to be aligned. So I selected both, the line and the midpoint, and now this one shows up and I can make it coincident. And now our sketch is fully defined. It's a bit of a bummer that here it already realized what I want to do, because before, let me reverse it, you see this right here. This little, I'm not sure what the English word for it is, it's Knick in German. This little pointy edge. And we can, that always indicates that something might be wrong, because usually our arcs or any round lines will be with a smooth transition to the next straight line if there is one. And that is, or that indicates that we are missing a tangent constraint, which is that one. So I can click on a tangent constraint, select the two curves. You have to play around with what's the stationary and what's the motion curve sometimes. So let me try it this way around. Okay, I'm clicking on OK just to show you. If it's kind of weird afterwards, that's no big deal, because now we see that one. We have to make it horizontal, and that fixes the problem. And now that one needs to be 16 again, and I think everything looks fine. The sketch is fully defined. So as you saw before, it was intelligent enough to infer these constraints, but in case you have a problem like this sometimes, that the line is not, or sometimes it's also either you have this knick, this little pointy edge, or sometimes your sketch is not fully defined and it seems like you have given all the measurements that there are in the technical drawing. And if that's the case, then often you're missing a tangency constraint, and you should be able to see that, because then the transition between the arc and a line is not smooth. So that's one thing to look out for. We are done with our arc here though, and can now use the sweep along guide function to select the curve, and it now has selected my arc. That's not correct. We need, so I'm starting the function again. So we need our section curve, which is that one. We need the guideline, which is that. And now you can see we already get a preview, and I say that looks perfect. So I click on OK, and here we have our first part. Next, we need to do this. And as I said, I just want to do one first and then mirror it afterwards. And I would say that it makes sense to draw the guideline first now, not the section, because then we already have this point down here, and we know how exactly we should draw the section and where. So let's go back to the sketch function, choose this right here to sketch on, and now we are just doing this line. It starts with a distance of 2 to the top. So the top is 26 right here. So we have to do 24 and 0. Now we need a length of 6. That's what it says up there, if you can see in the technical drawing. And I'm switching to the profile function again because it's easier. Do a radius or an arc right here. I haven't given a radius yet. And it did something wrong. Yeah, haven't given a radius yet. I'm gonna do that later again. I'm doing a line. I'm also not giving any measurements so far. Doing another arc, and this last little line, which will be only 2 millimeters in the end. And now we start giving all of our dimensions again. So let's maybe start with the 32 from here to here. It's almost good so far. Next we can do this line and make it vertical, sorry, because it should be vertical. So if you can't see that, that's that little 2 millimeter straight line right here. And also let's set it to 2. This radius is or should be 12. Here we don't have a length, so let's hope it will be inferred after giving all of the other measurements that we have. We have a radius of 12 right here. And now, to me, it looks like we have given everything that we know, and it's still partially defined. And now that's very nice that it happened, because I think the problem is exactly what I mentioned before. We are missing tangency constraints. And here that looks tangent to me already, but as you can see right here, there's a little dent. That's the word that I was looking for, a little dent. So in this case, we have, it's hard to see, I guess, but it's visible through that, because the radius, if you drag that, it goes on, and it should be, okay, maybe that's not the indicator, sorry. Forget about that. But you can see it looks not smooth right here. So if I'm clicking it, our suspicion is confirmed, because you can see right here this little blue line, that's a tangency constraint. So these two lines are tangent, these aren't. So let's just select them both, click on tangent, click on OK. And now, okay, it looks better, but still it's partially defined. So let's just check the other things and give them the tangency constraints. Maybe we have a problem here. Okay, that didn't seem to be the problem. Maybe I still missed something. And in that case, if you're at that point where the sketch is still partially defined and you don't know why, you can try to start and drag lines up and down and left and right and see what is still moving. And I see, okay, the only thing that is still moving is this, which is moving up and down. So that's very easy to fix. We can just select these two and say 24 again. I'm not sure why it didn't automatically create that dimension in the beginning, but now we have it, and now everything's black and the sketch is fully defined. So we have our guideline, and now I want to point something out to you. You had here we did the guideline, which is connected to, or in that case is exactly in the middle of our base, okay, of our section curve. Now we have the guideline right here in the middle, so it won't be connected to section curves, because the guideline is here if you look from the bottom, and our section curves are away from that. That's no problem for Sweep Along Guide. You have to imagine it like a guideline which will be used but on your section curve. So the extrusion or projection, or however you would call it, will always start from the section curve and then follow the direction of this curve from there. So it doesn't matter where the curve is, it's just taking its direction, not its position, okay? I hope that's clear, because I think it's always nice to also understand how the functions are working. and we are going to go into our last sketch, which is this section curve. And it's pretty similar to what we have done before. First we can check how far this is away from here. Or maybe let's first draw it and then be concerned about where exactly it should be. So I'm just drawing it somewhere in the general direction where it should be, with a distance or with a length of 4 right here, then 3 right here, like that and like that. And now we need, let me move that out so it's a bit easier to see. And now we still need this little arc down here. Selecting these 2 points and stating that from here to here the distance should be 0.5. Now I think I need to do a point, right? Yeah. Okay. And now we only need to see where exactly it should be. First of all, we can see that the guideline, so the end of the guideline, which is the last point out here, which is 32 millimeters apart from our middle point, should be 2 millimeters apart. In 2 millimeters distance. So we can just 32 minus 2. We can just state that the middle point right here should be 30 millimeters away from our middle point. No, that was wrong, sorry. Of course it's the outer line. No, wait. I'm confused. Yeah, it should be the outer line. The outer line should be 30 in a distance of 30. Yeah, and now it also lines up with the middle point right here, I'd say. And also we need to find this distance. So let's have a look where we can find this. And I think we can find it here. You can see the 14 millimeters are, and here you have to look closely, from this line to this line. And what are those lines? Let's have a look in this picture. Here we can see that the round edges are on the outside, of course, that's what we have drawn. And if you look from this direction now, then you will see this edge, of course. Here you can remember our introduction into technical drawings. You will see this edge, which is the inner line. And then you will also see the round part sticking out, okay? And the round part sticking out is the second line right here, okay? So here you're seeing the side of the round part, so to say, and here you're seeing the flat part. So we know from the middle to the outside of the flat part, so to here, which is here in our case, it will be 7 millimeters from the middle. So let's click here, and now we could click here and say that should be 7. Nice. Sketch is fully defined. We can go out of our sketch. We can use our sweep along guide function again. Select this as the section curve, which is already selected. Nice. Select the guideline. And now you can see that our new element is drawn as it should be. And we just need to select the unite boolean so that we can immediately unite it with our other part. And you see we have our first element right here. And now we just have to use the mirror feature, which you should already know. Select the feature. I always like to select them from the model history. The sweep, the last thing we did, you see, is that one. We select the plane, and because we have done all of this thinking in the beginning, we can now simply select this plane. It shows us, okay, here will be the corresponding mirrored point of that point. That looks good. And once we click OK, we have the whole part done. So that was a pretty long video. As I see, we have we took 30 minutes, but I'd say without all the talking and slow explaining and getting faster with the thinking, which of course I did very slow now in the beginning, you can model something like this in 10 minutes, give or take. So yeah, that's the part that I could imagine for an exam to get